Okay, so this will be the last section for the Exponents and Logarithms chapter. All living things have carbon-14. Once they die, the carbon-14 is not replaced and begins to decay. The half-life of carbon-14 is approximately 5,700 years. This info is used to find the age of many archaeological finds. We will first find the annual decay rate for carbon-14, and then we'll answer some typical carbon-14 dating questions. All right, so let's find the annual decay rate. So we have a population decay. Population decay. So we're going to use n of t equals n sub 0 times e to the negative RT. All right, if it were a growth, it would be positive RT. All right, so the half-life is 5,700 years. That means you have half of it left after 5,700 years. All right, half-life is half of the original. So n sub 0 is the original. That means n of t is going to equal half of the original. Okay, and that equals n sub 0 times e to the negative r, and t is 5,700 years. All right, so t is going to be 5,700, and that's in years. All right, if t is in years, the annual decay rate, once we solve for that, is also going to be in years. All right, so since they give us t in years, when we solve for r, that's going to be in years as well.
Excuse this interruption.
As usual, we have a constant term in front of the e. This is n sub 0 times e. The opposite of times n sub 0 is divided by n sub 0. We do the same thing to both sides. N sub 0's cancel on the right, and they also cancel on the left, and we are left with 1/2 equals e. Leave some space in front of the e to the negative r times 5,700, which is going to be negative 5,700 r. All right, so the exponent is on e. So the base here is e. We're going to use log base e, which is natural log. All right, you want to do the same thing to both sides. The natural log and the e cancel, and we're left with negative 5,700 r. On the left, ln of 1/2. All right, the opposite of times negative 5,700 is divided by negative 5,700. On the right-hand side, it cancels. On the left, we're going to go to the calculator. ln of 1/2 over negative 5,700. All right, ln of 1/2, or 1 divided by 2, and that whole thing is divided by negative 5,700. Okay, this is my numerator. This is my denominator. Hit equals, and rounding off, 0.00012. All right, normally we convert that to percentage, but we're going to be using that in the examples. So I am just going to leave it as a decimal. Okay, and like we said, that is the rate per year. All right, example 1. How long will it take for 80% of the carbon-14 to decay in an animal after it has died? All right, so 80% of it has decay. has decayed. So if we started with 100% and we lost 80%, we are just left with 20% of the original. Now, if you recall, n sub 0 is the original amount or the original population. So if we were to do 20% of the original, that's equivalent to 0.20 times n sub 0. Okay, that's 20% of the original. We are looking to solve for how long it will take. So that is going to be t. All right, and we said the decay rate for carbon-14 in the last example was this amount per year. All right, so once again, we're using the decay formula. So that's going to be n of t equals n sub 0 e to the negative RT. All right, n of t is going to be 20% of the original, so that's 0.20 times n sub 0. All right, that's 20% of the original. And that's going to equal n sub 0 e to the negative r. R is 0.00012. So r is 0.00012. And that's times t. All right, as always, we want to get rid of n sub 0. We divide both sides by n sub 0. All right, because n sub 0 is times e, and the opposite of times is divided by. On the left, n sub 0 cancels. On the right, n sub 0 cancels. And we're left with this mess here. So we have 0.20. And leave some space, and that's going to equal e to the negative 0.00012 t. Remember, the natural log is log base e, so we're going to do the natural log on both sides of the equal sign. All right, natural log and e cancel, and we're just left with this right here. Really, we don't even have to rewrite it. I'm just rewriting it to make it neat. You can just leave this here as is. All right, ln of 0.20 is going to equal negative 0.00012 t. The opposite of t times this number, all right, because this is times t, is divided by that number. So I'm going to divide both sides by negative 0.00012. On the right-hand side, it cancels. On the left-hand side, calculator. All right, so we have ln of 0.20, close parentheses, divided by negative 0.00012. Hit equals, and rounding to the nearest whole number, since it's 0.9, I'm going to round up 13,412. All right, that's your estimation for t. And since r was at the rate per year, the units on t are going to be in years. So 13,412 years is your value for t. All right, example 2. Suppose a bone is discovered and has 60% of its carbon-14. How old is the bone? All right, 60% of its carbon-14. That means it has 60% of its original amount. All right, so 60% is the same as 0.60 of when you're dealing with percentages, of almost always means multiply. And of course, the original amount is going to be n sub 0. So 60% of the original amount is 0.60 times n sub 0. All right, as usual, this is a population decay. All right, so our tried and true formula. N of t equals n sub 0 times e to the negative rt. All right, so we are left with 60% of the original amount. So n of t is going to be 0.60 times n sub 0. And that equals n sub 0 times e to the negative r. What did we say the rate was for carbon-14? Let's look back. All right, in the beginning, we said the decay rate for carbon-14, 0.00012 per year. All right, so R is going to equal 0.00012. And they're asking how old is the bone, so we are solving for time t. All right, so e to the negative r, the r is going to be 0.00012. That's in place of r. Three zeros, right? I should have wrote 3 zeros here. There you go. And t is just t. We're solving for t because we want to know how old it is, so we have to find the time. All right, so basically this r, whoops, this is r right here. This r is times t. All right, so from there, once you got the setup, pretty simple to solve. All right, we have times n sub 0 on both sides. The opposite of times n sub 0 is divided by n sub 0. Okay, on the left, it cancels. On the right, it also cancels. And we are left with 0.60 equals, leave some space, e to the negative 0.00012 t. On this side, we have base e. So we want to do log base e on both sides. Log base e is the natural log. Okay, and the natural log of e just cancels. And we are left with ln of 0.60 equals this right here. We're just left with the exponent. Okay, this is t times negative 0.00012. The opposite of times that is divided by that. So I'm going to divide by negative 0.00012. I do that to both sides. On the right side, the same term over itself, that cancels. Whoops, same term over itself, that cancels. We are left with t. And that equals this. Let's go to the calculator. ln of 0.6. All right, ln of 0.6, close parentheses, divided by negative 0.00012. .00012. It equals, to the nearest year, since it's 0.8, we're going to round up, 4257. All right, 4,257 years. That is your approximation for t. How did we know this was in years? Because the rate, the decay rate, was per year. All right, we solved that in the beginning. That was the decay rate per year for carbon-14. All right, we got that number at the beginning. All right, last one. Suppose an animal dies today. How much of its carbon-14 will remain after 250 years? So, of course, 250 years is going to be the value for t. All right, the decay rate for carbon-14 that we've been using, that is 0.00012, and that is per year. All right, so we have a decay here, population decay. N of t equals n sub 0 times e to the negative RT. Now they ask how much will remain. So what do they mean by that, how much? Well, what they mean is the percentage of the original. All right, so I'm going to let the percentage of the original, I'm going to let that equal P. So just like in the other problems, when we multiplied the percentage times n sub 0, the percentage of the original is going to be P times n sub 0, right? Percent of original. I'll let the percent equal P. Of means multiply, and the original is n sub 0. So n of t is how much we end up with. So the percentage of the original is how much we end up with. That's going to go in place of n of t. So that's going to be P times n sub 0. And that's going to equal n sub 0 times e to the negative r, which is 0.00012. And times t, that is 250 years. All right, so we are actually solving for P. All right, P I just used for percent. You can use X if you want, but P is just the percentage. All right, so how do we solve for P? Well, it's quite easy. All right, we have it times n sub 0 on both sides. The opposite of that is dividing by n sub 0 on both sides. It cancels on the left, it cancels on the right. And we're going to do e to the power of negative 0.00012 times 250. This right here is your exponent on the number e. Remember, e is not a variable. E is not like x. E is an actual number. So you need to find that on your calculator and do e to this exponent right here. I'll show you on the Google calculator, and that's going to equal P. All right, let's see on this calculator. Remember, ln is log base e. If you hit the inverse button, it'll give you the e to the x, so that's what we want. So we have the number e, and in the box for the exponent, I'm going to use parentheses, and it's going to be negative 0.00012 times 250 years, close parentheses. Okay, so that is the exponent on the number e. And again, the way I found the number e, I did inverse ln. That's probably going to be the case on most calculators, inverse ln, and you'll have your e to the x button. Anyhow, hit equals. And I'll do 4 decimals, 0.9704. So rounding off, p is approximately 0.9704. How do we convert that to a percentage? Well, you just move the decimal over 2 places, and that's going to be 97.04%. All right, because remember we let p equal the percentage, but you have to convert it to, when you let p equal the percentage, it's going to give you the percentage as a decimal. Okay, so to convert it, you're going to have to move the decimal to the right 2 places. But they're asking how much of it will remain, about 97%.